A lot of features of a quadratic graph can be determined by examining the quadratic expression that represents it. First, you have to remember the parent function. This is the graph that's transformed to create all other quadratic graphs. Let's first examine what happens when we add or subtract a value from x squared. Using the expression x squared plus 10, we can evaluate a few negative and positive x values and analyze the results compared to x squared in a table of values. Remember, each value of the table is found by substituting x values into the quadratic expressions. If we add a row to the table with the values of x squared at the same x values, we can look for a pattern in how the values change. Every y value for x squared plus 10 is 10 greater than every y value of x squared. Going through the same process for the quadratic expression x squared minus 3 results in the following table. Each value of x squared minus 3 is 3 less than the value of x squared. What this information tells us is that if you have a quadratic expression that consists of a quadratic term and constant, the graph of the quadratic will shift vertically based on the constant term. If the constant term is positive, the graph shifts up on the y-axis. If the constant term is negative, the graph shifts down on the y-axis. The red graph is of the parent function of a quadratic, f of x equals x squared. The blue graph is of the function f of x equals x squared plus 10. Notice that it starts as the parent function and then is shifted up 10 units. The green graph is of the function f of x equals x squared minus 3. Notice that it starts at the parent function and then is shifted down 3 units. Multiplying x squared by different values can also affect the graph. The table provided compares a positive coefficient greater than 1 with a positive coefficient between 0 and 1 with a negative coefficient. When the coefficient of x squared is 2, the y values of x squared are doubled. When the coefficient of x squared is negative 2, the y values of x squared are doubled with the opposite sign. When the coefficient of x squared is 1/2, the y values of x squared are divided in half. The red graph is of f of x equals x squared, the parent function. The blue graph represents f of x equals 2x squared. Notice that it's narrower than the graph of the parent function. The green graph represents f of x equals 1/2 x squared. Notice that it's wider than the graph of the parent function. This means that the graph of a quadratic will be stretched or narrower with a coefficient greater than 1, and that the graph of a quadratic will be compressed or wider with a coefficient between 0 and 1. When a quadratic expression has a negative coefficient, that has an additional effect on the graph. The negative coefficient will reflect the entire graph over the x-axis. The red graph is of f of x equals x squared, the parent function. The purple graph is of f of x equals 2x squared. Changing the coefficient to a negative 2 would cause the purple graph to reflect over the x-axis. This final graph is represented in blue. In summary, you can determine how a quadratic expression affects the graph of a quadratic function if you remember a few key points. Number 1, adding a value to the quadratic term shifts the graph up. Number 2, subtracting a value from the quadratic term shifts the graph down. Number 3, multiplying a quadratic term by a positive number greater than 1 stretches the graph. Number 4, multiplying a quadratic term by a positive number between 0 and 1 compresses the graph. Number 5, a negative coefficient of a quadratic function will reflect the graph over the x-axis.